So as a free fall problem goes, let's do a relatively simple starting example. Since we've already done problems before, I'm going to go back and say that what we're looking at right now is an exercise, not a problem. And as an exercise goes, let's say you throw a ball upwards into the air with an initial speed of 25 meters per second. What's the maximum height reached by the ball? That's generally a good starter free fall question. Standing on the ground by yourself, throw a ball upwards into the air. What is the maximum height reached by the ball? Now, there's a lot of reasons this is a good starting place, but please take a moment, follow your quick set of steps, write down your 5 motion variables, identify what's been given in this problem, and maybe put a question mark next to what I'm asking you to find. It is not uncommon in problems that involve things going up and down for your textbook to change all the x variables and make them y variables. I won't. I did just now to call your attention to it. But if you start looking at, some people ask if the videos that are on College Board are good. They are. But a lot of times in the vertical component, they will change delta x to delta y. They'll sometimes be way extra and put lots of y's there just to, make sure you understand they're talking about the vertical direction. I kind of find that if you can tell from context what we're doing, then perhaps we don't have to do all that and we can just be consistent. But that's up to you. If you want all that extra information, you may want to put it there. I'm going to leave it like this. Now, if you've done what I've asked, you have figured out that there are a couple things here that are given. But I would like to encourage you to start any problem from this point forward by identifying what direction you call positive at the start of your problem. Because doing motion problems is easy. If I want to play in the gray area, I play in what you call positive versus what you call negative. And you understand that that's probably going to be a good place for me to play. And if you don't understand why I'm saying that, give me a chance tomorrow. Because you often make assumptions about whether your answer should be positive or negative. Don't make assumptions. Know from the beginning. State what you will call positive at the start of your problem. By doing this, I know that my initial velocity is positive 25 meters per second. Now would be an excellent time to mow the lawn. We're not trying to do anything here. Now, once you recognize that this is a free fall problem, it's easy to put down what the acceleration is. It's knowing when it's free fall and when it isn't. If your object is being accelerated by gravity, it's a free fall problem. So look to see if that's true. Once this ball leaves my hand, the only thing that could possibly be acting on it is gravity. So usually it's not hard to detect if it's a free fall problem. But gravity is directed downwards. So I will explicitly put a negative sign here. Please note that I'm starting to put positives and negatives next to the numbers as I write them. I know that we assume a number is positive unless told otherwise. I'm going to stop assuming that quite a bit for the next couple of weeks. And I will be expressly telling you if something's positive and negative when I write it down. I would encourage you to do the same thing. Because I don't have to do this problem with up being positive. I can do this problem with down being positive, and it works just fine. You tend to think up is positive all the time. Stop. Declare what is positive. Take control. That's not enough to solve the problem. So what am I missing? Yeah? Yeah, its maximum height is reached when it comes to rest. So that's something you have to bring to the problem. So in this case, this problem only gave you one piece of information and implied 2 others. That's really the hallmark of free fall problems, that they're implying something that you have to bring to the problem. Now, yeah, this is now no longer interesting. You cross out the time, solve for something that has delta x and the rest of these variables in there, and you'll figure out how high this object goes. I don't want to minimize that, but that's the least interesting part, right? 0 minus 25 squared equals 2 times negative 10 delta x. 625 divided by 200, 31 and a quarter. comes out naturally to be positive. That's not a surprise. Now, the math is not interesting until it is. It came out expressly positive, telling me that my object is 32 meters above where I started. Begin being careful with direction so that your answers tell you not just the size of the answer, but the direction of the answer. In the beginning, you might think you're getting the right answers because they come out to be the right number, but pay attention to direction. How about another one? Yeah. I used the v squared minus v naught squared equals 2a delta x. Yeah, there's different ways to write this. I've been writing it this way for years.
Okay.
And just so you know, I write it this way because if you know what you're looking for, this is the work energy theorem, something we'll learn later in the year. The left side of this is the change in kinetic energy, and the right side of this is the amount of work done. And in this class, that has some other values as well. So that's why I write it like this, because we'll see some parallels. How about this? You're playing ball with yourself because, well, you know, maybe your friends didn't show up that day. So you throw a ball into the air at 15 meters per second. When does it return to your hand? Similar question. Can you do this one? Try it. You throw the ball upwards 15 meters per second. When does it return to your hand? The bell rings in like 2-3 minutes, which is way more than enough time to get this problem done. When I work this problem out, however, I'm directing downwards as being positive just for fun. Since I'm solving for time, if I do this wrong, we'll know about it. When you do this problem, though, you might find that there are alternate ways to do this problem. And I don't know how you're going to do it. I'm assuming you've made some assumptions already. Like the initial velocity for me is negative 15 meters per second. And my acceleration is positive 10 meters per second squared. What else did you do? Generally, there's two schools of thought about what to do next. What did you do? Yeah.
I made another list, another motion list to show like when the ball's coming back down.
Okay, so you made the final velocity 0
Yes, sir.
and solve for the time. You could probably just double it too. It's going to have the same trip down as it had to trip up. That will work. So how many of you did that? That works. That's just fine. But there's an alternative. Anybody know what the alternative is? Yes, sir.
Is that displacement is 0?
Sure, the ball comes back to where it started. I could solve this in one step by saying the displacement equal to 0. It doesn't tell me how high the ball went, but it tells me when the ball returned to my hand, which is all that was asked. Efficiency is sometimes important. By the way, if you did it correct, 3 seconds. That's how long it takes to come back to your hand. Pretty sure. It's been a while since I did this problem, like 45 minutes. But I think it's 3 seconds. And if you want to stay, I'll work it out. But if you have to go, please, get out there before you get poured on.
Thank you, Mr. Schultz. Have a great
You're
day.
welcome. Have a great day. So there you go. I get t equals 0 and t equals 3.